Okay, for today's lesson, I didn't make a new toolkit, but I would like for you to look for your regression line toolkit. I didn't make a whole new toolkit for this because what we're going to be doing is pretty much the same as everything that is on this toolkit. Okay, on this practice, it says, suppose we're talking about counts of Midwest wolves beginning in 1990. And these are the estimates. So this is the year since 1990. It says to draw a trend line on the graph. So I'm going to graph these points. So over 0 up 200 is right here. Over 2 up 400 is right here. 5 up 600. 7 up 1,000. 10 up 1,600 is right here. And over 13 up 3,200 is going to be right here. Okay. It says to use your calculator to find both the linear and exponential regression. So we already know how to find the linear regression, and you got that toolkit out to help you. As a reminder, we're going to go to press Stat, Edit, and type in these numbers. So go ahead and type in these numbers into the table. Into Stat, Edit, we're typing these numbers in. Okay, to get the linear regression, we press Stat, go over to Calc, press 4, and Enter. Okay, the linear model is this, and this is the line of best fit. It says to round to the nearest hundredth. So this is going to be y equals 212.34 if I round to the nearest hundredth. X minus, because it's a negative b value, minus 142.78. Okay, this is my line of best fit. This is the line that fits through the points the best. Okay, you might not have your R value turned on, and so we did write that on this toolkit. To turn on the R value, we press second 0 and go to diagnostic on. Second 0. I can jump down to D right here and do diagnostic on and press enter. Okay, diagnostic on, it should say done. So now when I do stat calc 4 again, it's going to give me the R value this time. Okay, the R value, it says to round to 4 decimal places, is about 0.9301. Remember, this is the line that fits through the points. The R value tells us what about that? It tells us how well it fits through these points. So looking at that, I would say that that fits pretty well. Okay, now we're going to use the exponential model. So before we have done stat, calc, and option 4, okay, I want you to look at this list for exponential model. Instead of stat, calc 4, we're looking for exponential. And you should see that today when it asks for exponential, we're going to do stat, calc, and then 0, stat, calc 0 for the exponential regression. Okay, this time it's not going to look like mx plus b, right? It's going to look like a times b to the x. So it's going to be y equals a is 226.74. B is 1.22 to the x power. Okay, so if it asks for a linear function, that's going to be in y equals mx plus b form. If it asks for an exponential function, it's going to be a times b to the x. And the R value is about 0.9946 if we round to 4 decimal places. That 7 would round that up to a 6. Okay, looking at this, which one is a better fit? Well, I can see that this R value is 0.9301. This R value is even closer to 1. So the exponential is a better fit because R is closer to 1. Now, does that mean that these points are closer to making a straight line? No, it does not. So this R value, the R values this time, the closer it is to 1 is the closer to make a perfect exponential growth curve. Okay, if R was 1, it would make a perfect exponential growth curve. If R was -1, it would make a perfect exponential decay curve. So keep that in mind. We're not going to say that if it's close to 1, it's going to make a perfectly straight line. Okay, that means it's going to be close to making a perfect exponential decay or growth curve. Based on the model, what is the percent growth in the wolf population? So where would we look here to tell what the percent growth is? Well, this is a times b to the x. The a value, this would be the y-intercept of the exponential model of best fit, and it's multiplying by 1.22. So anytime I multiply by 1.22, I always multiply by what I keep. That means I am keeping 122% of what I had before. How far away is that from 100? That is 22% more than we had before. This is 22% growth. Use the model that you believe to be best, which we said was exponential, to calculate for the following years. Okay, since we're going to use this to predict, you could plug these numbers in by hand. I'm going to store it so that I can look in the table. So I'm going to press Stat Calc 0. And before I press enter, I'm going to press vars, y vars, enter, enter. So this is going to calculate the exponential regression, and when I press enter, it's going to send it to y equals for me. Okay, so if I'm predicting 1994, the time since 1990, how many years has that been? That has been 4 years. Okay, so time since 1990 is x. So let's look in the table, second table, for when x is 4. Okay, for when x is 4, I see that it's 510.12. Okay, 2001 since 1990 would be 11 years. So I'm going to look in the table at 11 when it plugs in 11 for me, and I get 2108.3. Now I'm going to go backwards. I'm going to look for these y values. 2582, I notice right here, for 12 years after 1990, which would be the year 2002. And 5809, I notice, is 16 years afterwards. So that would be 2006. Okay, so the questions you see today are mostly going to be like those same 4 questions in the linear regression. You're going to find what fits best, find the equation of best fit, talk about how well it fits, looking at the R value, and then some are going to give you an X value and ask for a Y. Some are going to give you a Y value and ask for X. You're going to predict a Y or predict an X. If you are predicting, that is when I would suggest that you store it and then look in the table in order to predict. Okay. Anytime it gives you years, you should use 0, okay, and 0 and 1, or in this case, it's going to be years since 1965, so this would be 5 years later. Okay, this would be 10 years later. So if it is years, when it's exponential, you do have to use x equals 0, or else the numbers will get extremely too big for the calculator to calculate. So you're going to do the linear and the exponential model and see which one fits better. These are actual industrial average prices, so you are going to these are making actual predictions. Okay, looking at number 3. You're going to need to create a table to find the exponential regression. Okay, so make your own table, and it'll only have two points in it. Okay, so plug in what the two data points are and find the exponential regression. And then this one asks, so when you get a y equals a times b to the x that fits through the points in the table, it asks to approximate how much it went up by each year. So you're going to need to look at the b value and decide what percent growth or decay that represents. Let's see. Okay, so it's more of doing the same thing. Keep in mind for number 8, we're not looking at how close this is to making a straight line, right? We're looking at how close it is to an exponential growth or decay curve.